My grandma had problems with her pregnancies because of something in her blood, where like her body would attack.
Hemolytic disease of the newborn.
Is that what that is?
Mm-hmm. Hopefully that's the answer that he gave you.
I think it was, but I don't know if he...
Yeah, so that has to do with RH. So if the problem you have is A, B, and O antibodies can't cross the placental barrier. They're too big, they can't go across. RH antibodies can. So the way our body works, and you'll learn in chapter 22, we only develop antibodies once we've been exposed to something. So like right now, if I've never been exposed to A or B blood, and let's say I receive a transfusion of A or B, my body's not going to do anything. It's going to start building up an immune response, and so 4 to 7 days later, now I'll have antibodies. So what happens a lot of times is, if the mother is negative and the fetus is positive, it's a problem. Why would that be?
Because they would attack each other. Well, no, the mothers would attack.
Mother would build up antibodies.
Yeah, mother would
Attack.
because it's the main, so attack.
She's going to attack the fetus, right? So what if the fetus is negative and the mother's positive?
I don't know. Same?
It's the same thing.
It's not a problem.
Not a problem.
I was going to say, because adults have livers that can...
Well, yeah, essentially because, so for one, the adult has a much more developed immune system. The fetus has virtually no immune system, and even if it did attack, it's so small. There's just no, it's like the ants trying to squash the dog. It's just not going to happen. So basically the fetus just doesn't really have much immune system, so it's not a problem at all. So the issue you get is once, let's say there's a complication during pregnancy where the placenta tears even just a little bit, the mother's body recognizes, hey, that's a different blood type, starts making antibodies against RH. And then, 4 to 7 days later, those antibodies can cross the placenta and attack the baby's blood. So usually in the first pregnancy, as long as there's not complications, it's not a problem because the mother's body never detected a difference. But during birth, there's always going to be blood exchange. The placenta tears away from the uterine wall, there's always blood exchange. So for the second pregnancy, if the second baby is positive and the mother's negative, it's going to be attacking it from the get-go. So that's probably what happened.
It's only one of my aunts that she said that she had a lot of trouble with. She was the second or third.
Yeah.
So.
Yeah, and so that can happen. Now, more recently, you give them a shot called Rogam. It disables those anti-RH antibodies, and there's no problem. So now, if they know the mother's, RH negative, they just give it a shot, and there's not an issue, especially after.
So how long did they come up with this RH disabler? How did they do that?
It's just a drug that disables the antibody. I don't know exactly how it works.
You got the scope of this class.
And I don't, and I don't know when it became really popular. For some reason, I'm wanting to say like early 90s is when they started using it a lot, but I don't know. I don't know why that number even jumps into my head. It just does, but so probably unreliable. But, so anyway, that's probably what was going on. So let's blood type. You want to know what type of blood you have. So pretend this is red instead of blue. I don't have a red. So I put a drop of blood here, drop of blood here, drop of blood here, and I want to find out what type I am. So I put anti-A first, anti-A antibodies, anti-B, and anti-RH. So the way that these antibodies work is they agglutinate. They clump all the red blood cells together, grab them all together, and then hold them. So what you would see if there's a reaction is you look at these slides, and as you move the slide back and forth, it look like little red grains of sand in there. If you've done it in lab, you already know that. So you'll see that agglutination if there's a reaction. So I put in anti-A, and nothing happens. I put an anti-B, and I get this agglutination. I put an anti-RH, and I get agglutination. What's my blood type?
B positive.
B positive. Makes sense? I put in the antibodies that would attack A. So the gang's special hitman that goes after the A gang, and nothing happened. He didn't find anybody. Those antibodies did not detect any A antigens, so nothing happened. So we know that it's not A. But over here, the anti-B hitman did find some B, and he grouped them all together. So we know he's got to be at least B. And they found RH, so we're B positive.
So if all of them clump, then are you AB positive?
Yep.
And if none of them clump, then you're O negative.
Yep. Everybody good with that?
Okay.
You guys had that way faster than yesterday.